You will be able to use elimination in order to solve systems of linear equations. So here is my system of equations. 0 equals negative 12y plus 3x, and 4 minus 6y equals negative x, and they are nowhere close to standard form. So we need to first line up the terms, because elimination works by getting one variable positive and getting the other one negative and having them be the same number, then adding the equations up, therefore eliminating that variable. But it only works if the variables are lined up. X plus y equals some number. We don't have that, so that's what we need to do. These it's not obvious how they should be lined up. So the first thing that we should do is let's just rewrite our first equation. 0 equals negative 12y plus 3x. And my x and my y's look like they're over on this side, and my 0's over here on that side. X plus y equals some number. Now, how am I going to line it up with the bottom? Well, first things first, I'm going to see where the equal sign is. I'm going to line up the equal signs like that. And then now, what's on the left side of the equal sign? 4 minus 6y. So let's write that. 4 minus 6y. That's the left side of the equal sign. What's on the right side of this equal sign? Negative x. And now that the equal signs are lined up, I can see what I need to move where. Now, for my top equations, my x's and y's are all on one side. I have my y plus my x equaling some number. So I can actually just leave this alone, because all my x and y's are on one side, and then my constants are on the other side. Here, I don't have my x's and y's all on one side. What I want to do is I want to take this negative 6y and move it over here. That way, then my x's and y's will be all on the same side. So let's say I'm starting with 4 minus 6y equals negative x. I want to bring this 6y over. If I want to bring it across that equal sign, that means I need to add 6y to both sides. So plus 6y plus 6y. These will cancel, and now I'm left with 4 equals negative x plus 6y. And so that's what my bottom equation now is. So let's go back down and rewrite. If I have 0 equals negative 12y plus 3x, and now I'm going to write this one. 4 equals negative x plus 6y. But look, they still aren't lined up. I need my x's and y's lined up. So why don't I rewrite again? 0 equals negative 12y plus 3x, and then 4 equals, now I'm just going to rearrange my x and my y's. So instead of saying negative x plus 6y, instead I'm going to say positive 6y minus x. And finally, after like 3 steps, I lined up my terms. I have my x's lined up, I have my y's lined up, and then I have my constants lined up. Now, that was before we even begin the problem. Now we can begin the problem. Step 1, pick a variable and get a common multiple. Here's where we are. So I'm going to pick a variable. I can pick either x or y. It doesn't matter. Let's just go with y. I picked y, and let's get a common multiple. Well, I know that a common multiple of 6 and 12 is 12. Because I know 12 is a multiple of 12, but 12 is also a multiple of 6, right? 6 goes into 12, and 12 goes into 12. So my common multiple is going to be 12. Okay? Now, if my common multiple, actually I should write that down too. Common multiple is 12. Okay. Now, my next step, I am going to multiply the equations by the right factors. So this equation is already 12. I'm just multiplying that by 1, which basically keeps it the same. But what do I need to multiply this by in order to get 12? Well, 6 times 2 equals 12. So I had to multiply this by 2. But if I multiply this by 2, I need to multiply the entire equation by 2. So I'm going to take my entire equation and I'm going to multiply it by a factor of 2. So here we go. When we rewrite, I have 0 equals negative 12y plus 3x. Okay, and now I'm multiplying this bottom equation by 2. 4 times 2 is 8. 8 equals, let's see, 6y times 2 is 12y. 12y. Negative x times 2 is negative 2x minus 2x. There we go. Multiply the equation by the right factor. I multiplied it by 2. Now, what's my next step? Multiplying the equation by negative 1. Now, look. I have a negative 12 and a positive 12. So this top one already has been multiplied by negative 1. I already have a negative and a positive because remember, we're trying to eliminate. In order to eliminate, use elimination, one has to be negative, one has to be positive so that when we add up the equations, then they cancel out. Well, I don't have to do any extra work here. One's already negative. This is negative already. That's positive already. So now all I need to do is just add up the equations. And that's what I will do next. Let's add them up. 8 plus 0 is 8 equals 12 and negative 12 cancel out. And 3x plus negative 2x, that is going to be 1x. So 8 equals x. Or in other words, x equals 8. And look, we have a solution. Because normally we would have to solve, but we don't have to solve to get x. As soon as we eliminate that y, we now know what x is. X equals 8. Solved. Done. Okay. So, what now? Well, we need to substitute that variable. We need to substitute this x into one of the original equations. So, this is our original equation up here. But let's go ahead and substitute that in to the lined up version of that equation. Okay, so remember how we had to line it up? So we lined up the version of the equation. So now we're going to take this x equals 8 and I'm going to take it and I'm going to go up and plug it in to that equation right there. I could plug it into either one. So I'm going to say 4 equals 6y minus x. What is x? X equals 8 minus 8. There we go. And now my next step, I'm going to solve for the other variable. Solve for y. Okay. So if 4 equals 6y minus 8, if I add 8 to both sides, and this arrow is kind of in the way, but I'm left with this 8, negative 8 plus 8, that cancels out. 6y, 8 plus 4 is 12. So 12 equals 6y. Now let's divide both sides by 6. And y is equal to 12 divided by 6, which is 2. So y equals 2. X equals 8. And the solution to our system of equations is 8, 2. And that is the point where the system of equations, where these two equations intersect.